Hey guys, I am going to give the solution of assignment 2. This assignment based on Laurent series expansion and its examples or problem. So I have already given the proof of the Laurent theorem in the previous video. So I am going to give the brief solution of remaining examples or problem of the assignment 2. So let us consider the problem 2. So however here the given function f of z is equal to 1 upon z negative 1 multiplied to z negative 2, and where the given domain D, that is 1 less than mod of z less than 2. So you can see this domain is concentric circle circles, or in other words we can say that that is the annulus region. So now first of all we have to write the given function f of z in the simplest form, and that is, so now here 1 upon z negative 1 multiplied to z negative 2 can be written as 1 upon z negative 2 negative of 1 upon z negative 1. So now let us draw the region D. So here the center is 0. This is a required domain of the given function. So now further write the given function f of z as a standard form. So that is, so take the negative here, so that is negative 1 upon 2 negative z, and also take the negative from the second term, it will give positive 1 upon 1 negative z. So now here our main task is, in the first term which term we have to common, either we have to take the 2 or we have to take the z. So now here we have a two cases, that is if I take the negative 1 upon 2 negative z, so this can be written in the two form, that is first the 2 is a common, that is negative 1 over 2 1 negative z by 2. Second, we need to take the common z, that is negative 1 by z, here will be 1 upon 2 by z negative 1. But we have to take the point from the domain D. So if I take the z is equal to 1.5 and put this here, then what will be here, that is z by 2, that is the mod of z by 2, that is mod of 1.5 over 2. This value will be always less than 1, and this series will be convergent if the mod of z over 2 is less than 1. So this will be possible if I put the z is equal to 1 by 2 here, that is mod of 2 by z, that is mod of 2 by 1.5, that is greater than 1. In this domain the series will not be convergent, so this will not possible. So by using that we can write here, that is negative 1 over 2 in bracket 1 negative z by 2. Similarly, by using that, if I put z is equal to 1.5 here, then mod of z will be greater than 1. So we need to take the common z here. So take z as a common from the denominator. It will give z multiplied to 1 by z negative 1. So now further we need to write in the standard form, that is negative 1 by 2 1 negative z by 2 whole inverse. Take the negative as a common, that is negative 1 by z in bracket 1 negative 1 by z 1 by z. Sorry. So further we can write here, this is equal to negative 1 by 2 in bracket 1 negative z by 2 inverse negative 1 by z in bracket 1 negative 1 by z inverse. But we know that 1 negative z inverse is equal to 1 plus z square plus z to the power 3 plus z to the power 4 plus dot dot dot, and this series convergent for all mod of z has to be less than 1. And the second standard series, as we know that 1 negative 1 plus z whole inverse is equal to 1 negative z plus z square negative z to the power 3 plus dot dot dot. It is also convergent for all mod of z less than 1. So by using this series expansion, we can expand the both term like as. So now here this is equal to negative 1 over 2, that is 1 plus z by 2 plus z by 2 whole square plus dot dot dot. So now here will be negative 1 by z, that is 1 plus 1 by z plus 1 by z square plus 1 by z to the power 3 plus dot dot dot. So further simplifying, we can write here, that is negative 1 by 2, open the bracket, we will get negative 1 by 2 negative z by 4 neg negative z square over, that is 8 negative z to the power 3 over 16 negative dot dot dot, and here will be, that is the negative of 1 by z plus 1 by z square plus 1 by z to the power 3 plus 1 by z to the power 4 plus dot dot dot. So we can write, this is our required the Laurent series expansion of 1 upon z negative 1 and z negative 2. So we can say that this is our required final answer. So now in problem 3, we need to find the first 4 terms of the Laurent series expansion of the function f of z. So now here, so let us consider the given function f of z is equal to 1 upon 1 plus z square and z plus 2. So this can be written as that is a upon z plus 2, that is plus bz plus c over 1 plus z square. So by using the partial fraction method, we can find the value of a and the value of b and the value of c. So I am going to show you how to find the value of ABC. So now here, that is 1 upon z plus 2 multiplied to 1 plus z square, that can be written as a upon z plus 2 plus bz plus c over 1 plus z square. So see here, for finding the value of a, so forget this term, we need to forget this term, uh, so we need to put here z plus 2 is equal to 0. So now here value of z will be, that is negative 2. So now concentrate in the left hand side the whole term, this term. So we have to forget this term. So our remaining term will be, that is value of a will be, we need to put the value of z is equal to negative 2 1 in the expression 1 upon 1 plus z square, that is 1 upon 1 plus z square, that is negative 2 whole square. So value of a will be, that is 1 upon 1 plus 4, that is a 5. So we have already get the value of a, that is 1 upon 5. So now for finding the value of c, so we need to put z is equal to 0 for c. So if we put the value of z is equal to 0 in the whole term, that is 1 upon 0 plus 2, that is 0 square plus 1. Value of a, that is 1 upon 5 upon 0 plus 2, plus here we will get b multiplied to 0 plus c over 1. So by solving we get 1 upon 2, that is 1 upon 10 plus c. So by solving we get the value of c, that is 1 by 2 negative 1 by 10. So LCM will be, that is a 10, 2 5 is a 10, and 10 1 is a 10, that is a 1, that is a 4 by 10, and this value is equal to 2 by 5. So we get the value of c, that is 2 by 5. Now put the value of c and the value of a in this expression. Then above expression reduce to, that is 1 upon z plus 2, that is 1 plus z square, that is 1 by 5 upon z plus 2 plus bz plus, that is 2 by 5 over 1 plus z square. So now we have only task, that is one variable, that is b, a known variable, that is b. So we can put any complex number except 0 and negative 2 because we have already used. So don't put z is equal to 0 and z is equal to negative 2. So we need to put z is equal to 1, then 1 upon 1 plus 2 multiplied to 1 plus 1 is equal to 1 by 5 upon 1 plus 2 plus b plus 2 by 5 upon 1 plus 1. It will give 1 upon 6 is equal to 1 by 15 plus b by 2 plus 1 by 5. 2 by 5 divided by 2, that is 1 by 5. So now here we can get the value of b by 2, that is 1 by 6, negative 1 by 15, negative 1 by 5. So now here that here the LCM will be, that is a 30. Here will be 6 5 is 30, 15 2 is 30, 5 6 is 30. It will give, that is negative 3 over 30, and this will is equal to negative 1 by 10. So now further simplifying, we will get the value of b, that is negative 1 by 5. So therefore here we get the value of a, that is 1 by 5, value of b, that is negative 1 by 5, and value of c, that is 2 by 5. Put the value of a, b, c in above expression, then we will get the function f of z. So we can write the given function f of z as 1 by 5 upon z plus 2 plus negative z by 5 plus 2 by 5 over 1 plus z square. So now here the given function f of z can be written as 1 by 5 z plus 2. Take the negative 1 by 5 as a common. So we will get z negative 2 over 1 plus z square. So now here in the domain, our given domain, that is 1 less that mod of z less than 2. That is a concentric circle, we can say in the that is analysis. So if I take the any point between this region, so here we have to take the 2 as a common. So we will get 1 by 10, that is 1 plus z by 2. Because if I put the any number between 1 and 2, here the modulus of z by 2, modulus of z by 2 will be less than 1. So in this domain, this series will be convergent. Similarly, here we need to take 1 by 5. If I put the 1.5 here, it will give 1.5 to whole square, that is 2.5, which is greater than 1. So we have to take z square as a common, that is 1 by z square, take as a common, we will get z negative 2 over 1 plus 1 by z square. So now further this value is equal to 1 by 10 in bracket 1 plus z by 2 whole inverse. Here that is a negative 1 by 5. Divide this term by z square. It will give 1 by z negative 2 by z square. Or this term can be written as 1 plus 1 by z square inverse. But by using the standard series expansion, so we can write here, that is 1 by 10 in bracket 1 negative z by 2 plus z by 2 whole square negative z by 2 whole power 3 plus dot dot dot. So next we can write 1 by 5, that is 1 by z negative 2 by z square. We can write here 1 negative 1 by z square plus 1 by z to the power 4 negative 1 by z to the power 6 plus dot dot dot. So this can be simplified as, that is 1 by 10, open the all bracket, that is 1 negative z by 2 plus z square by 4 negative z to the power 3 over 8 plus dot 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 plus dot dot dot. So now here that is 1 by 5. So we need to express the all the term by ascending order. First of all, we need to find that the term 1 by z. So we need to multiply the first term by 1. We will get 1 by z. So now we need to find the second term, that is z square, 1 by z square. So we will get here by multiplying this term to the 1. We will get negative 2 by z square. Now we need to find the term having the term 1 by z cube. So we will get multiply this term by to this term. So we will get negative 1 upon z to the power 3. And we need to find that term 1 by z to the power 4. So we need to multiply this term by to this. So we will get here, that is positive 2 by z to the power 4 negative dot dot dot. So therefore we can say that our given function f of z can be expressed as multiply the whole term by 10, that is 1 by 10 negative z by 20 plus z square by 40 negative z to the power 3 over 80 plus dot dot dot. So this is our irregular part, and the second bracket having the all the principal part, that is 1 upon 5z negative, that is 2 by 5 z square negative 1 by 5 z to the power 3 positive 2 over 5 z to the power 4 negative dot dot dot. So we can say this is our required Laurent series expansion of the given function f of z, and this is our required final answer. So now in this problem we need to find the first four terms of the given function, four terms of Laurent series expansion of the given function f of z. So now here the given function f of z is equal to twice of z plus 1 over z to the power of 3 plus z square negative 2 times of z, where the domain that is 0 less than mod of z negative 1 less than 1. So this can be written as 2 times of z plus 1 over, take the z as a common, then we have z square plus z negative 2. Again this can be written as 2 times of z plus 1 over z times of z plus 2 and z negative 1. But we can see that our center is z negative 1. Center is 1, radius 1, and this term is already. So we have to take z negative 1 outside. There is 1 upon z negative 1 take outside. So we have to take here that is 2 times of z plus 1 over z times of z plus 2. So now by using we can write as 1 upon z negative 1. Let us suppose this function is, let us suppose this function that is g of z, that is g of z. That is equation number 1. So further we have to write the g of z is equal to 2 times of z plus 1 over z times of z plus 2. So by using the partial fraction method we can write here a upon z plus b upon z plus 2, because both factors are linear. So by using that we can, by using the partial fraction method we can find the value of a and b, and that is, so now here 1 upon z multiplied to z plus 2, and here will be 2 times of z plus 1, that is a upon z plus b upon z plus 2. So for a we need to equate this term equal to 0. So z is equal to 0. So now here we need to eliminate z here and substitute the value of z rest of the term. So that will be value of a will be, that is 2 times of 0 plus 1 upon 0 plus 2, that is 1 by 2. So for finding the value of p, we need to put z plus 2 equal to 0. So from here value of z is equal to negative 2. So now here, so we need to so now here we need to cancel this term and put the value of z equal to negative 2 rest of the term. The value of b will be, that is 2 times of negative 2 plus 1 upon negative 2, that is negative 3 upon negative 2, that is 3 by 2. So now here value of a, that is 1 by 2, and value of b, that is 3 by 2. So further the value of a, that is 1 by 2, that is z, and value of b, that is 3 by 2 upon z plus 2. But our given domain in that is 0 less than mod of z negative 1 and less than 1. So here the term that is z negative 1. So we need to put, that is z negative 1 is equal to t. So from here value of z is equal to 1 plus t. Then domain will be 0 less than mod of t less than 1. So replace the all z by t plus 1. So this will be 1 by 2 over t plus 1 plus 3 by 2, that is t plus 1 plus 2. So further simplifying, this is equal to 1 by 2 1 plus t, here will be 3 by 2, here will be t plus 3. So in this domain, if I take any value of t between 0 to 1, this mod of z will be less than 1. So now here we can write here, that is 1 by 2 1 plus t to the whole power negative 1. So we need to take the t 3 as a common. Here that is 3 by 2 upon 3, that is 1 plus t by 3. 3 get cancel out. So we can write here, that is 1 by 2 1 plus t inverse plus 1 by 2 1 plus t by 3 whole inverse. So we can put here, that is 1 by 2 in bracket 1 negative t plus t square negative t to the power 3 plus dot 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 plus 1 by 2, that is 1 negative t by 3 plus t by 3 whole square negative t by 3 whole power 3 plus dot dot dot. So this is our required series. So now we can replace the t by z negative 1. So now replace t by z negative 1. So our g of z will be 1 by 2 1 negative z negative 1 plus z negative 1 whole square negative z negative 1 whole to power 3 plus dot dot dot. Here will be 1 by 2 1 negative z negative 1 whole power 3 plus z negative 1 whole square by 9 negative z negative 1 whole power 3 over 27. So further simplifying we will get, so here will be, that is 1 by 2 plus 1 by 2, it give 1, negative 1 by 2. Take the negative from here outside, we will get, and multiply the whole term by 1 by 2, it will give z negative 1, negative z negative 1 whole square, positive z negative 1 whole power 3, negative dot dot dot. Similarly, also take the negative 1 by 2 as a common. So here will be, and a 3 also take as a common. It will give 1 by 6. And here will be z negative 1, negative z negative 1 whole square by 3 plus z negative 1 whole square, sorry, whole cube by 9, negative dot dot dot. So put the value of g of z in the equation 1. So now the equation 1 become, that is f of z 1 upon z negative 1 on g of z, that is 1 negative 1 by 2 in bracket z negative 1 negative z negative 1 whole square plus z negative 1 whole cube, negative dot dot dot, and negative 1 by 6, that is z negative 1 negative z negative 1 whole square by 3 plus z negative 1 whole cube over 9, negative dot dot dot. So here our function f of z will be 1 upon z negative 1 negative 1 by 2 in bracket 1 negative z negative 1 plus z negative 1 whole square, negative dot dot dot, negative 1 by 6 in bracket 1 negative z negative 1 over 3 plus z negative 1 whole square by 9, negative dot dot dot. And this is our required the Laurent series expansion of the given complex value function. So now this problem is same as previous in the problem 5. So let us consider the given function f of z is equal to 7z negative 2 over z plus 1 multiplied to z and z plus 2, and the given domain, that is a region, that is 1 less than mod of z plus 1 less than 3. So center, here the center, that is a, that is a negative 1, and the radius, that is r1, that is a 1, second is r2, that is a 3. So we can say this region, that is annulus. So its diagram will be, so this is our required domain, that is 1 less than mod of z plus 1 mod of less than 3. So this is our required domain. So first of all we have to write, because this term is here, so take z plus 1 outside, that is 1 upon z plus 1, here will be 7 times of z negative 2 over z times of z plus 2. So let us suppose that is 1 upon z plus 1, that is g of z. So now here g of z can be written as, that is a upon z, because in denominator both having a linear factor, a upon z and b upon z plus 2. So by using the partial fraction method we can find the value of a and b. So now here 7z negative 2 over z multiplied to z plus 2, this can be written as a upon z plus b upon z plus 2. So now for finding the value of a, we need to put z is equal to 0, and for finding the value of b, we need to put z plus 2 is equal to 0. So from here we will get the value of z is negative 2. So now for a, we need to eliminate this term z from here. So the value of a will be 7 times of, and put the value of 0 of the remaining term, that is 0, 7 multiplied to 0, negative 2 over 0 plus 2, that is negative 2 over 2, that is negative 1. And now for the coefficient b, so eliminate the term z plus 2 and take the whole term from here. So value of b will be, that is 7 times of negative 2 over negative 2. This value is equal to negative 16 over negative 2, that is 8. So we will get the value of a, that is negative 1, and value of b, that is 8. And this is our required answer. So put the value of a and b in given partial fraction, that is, so here the value of a, that is negative 1 upon z, and value of b, that is 8 over z plus 2. So now we need to put z plus 1 is equal to t, then we have value of z, that is t negative 1. So now replace the value z by t negative 1, then we have negative 1 upon t negative 1 plus 8 upon t negative 1 plus 2, that is, here will be, that is 1 upon 1 negative t, here will be 8 upon plus 2 negative 1, that is 1 plus t. So you can see that our domain will be, that is 1 less than mod of t less than 3. So now here, if I take the any value of t between 1 and 3, our modulus of t will be always greater than 1. So we need to take the t outside. So now take the t outside, then we have 1 by t negative 1, and here will be, that is plus 8 over t in bracket 1 by t plus 1. So write in the standard form, that is 1 upon t, take the negative outside, negative 1, here will be 1 upon 1 by t, 8 by t, 1 plus 1 by t. So finally we can write as g of z, that is negative 1 by t, 1 negative 1 by t inverse plus 8 by t, 1 plus 1 by t inverse. So by using the standard series expansion, we can write here negative 1 by t, that is 1 plus 1 by t plus 1 by t square plus 1 by t to the power 3 plus dot dot dot. Here that is a plus 8 by t, that is 1 negative 1 by t plus 1 by t square negative 1 upon t to the power 3 plus dot dot dot. So finally we need to simplify the whole term. Here that is negative 1 by t, that is 8 by t. So we will get 7 by t. That is negative 1 by t square, that is negative 8 by, that is a negative 9 by t square. Here will be, that is a negative 1 by t cube. Here will be 8 upon, that is a plus 7 upon t to the power of 3 negative 9 upon t to the power 4 plus 7 upon t to the power 5 negative 9 upon t to the power of 6 plus dot dot dot. So now replace the t by z plus 1 because we have already put the substitution. Here with it negative 9 upon z plus 1 to the whole square plus 7 upon z plus 1 to the whole cube negative 9 upon z plus 1 to the whole power 4 plus 7 upon z plus 1 to the whole power 5 negative dot dot dot. So now put the value of g in the given function f of z. So we will get f of z, that is 1 upon z plus 1 in whole bracket 7 upon z plus 1 negative 9 upon z plus 1 to the whole square plus 7 upon z plus 1 to the whole power 3 negative 9 upon z plus 1 to the whole power 4 plus 7 upon z plus 1 to the whole power 5 negative dot dot dot. So multiply the all term by 1 upon z plus 1. So our final, the Laurent series expansion will be 7 upon z plus 1 to the whole square negative 9 upon z plus 1 to the whole power 3 plus 7 upon z plus 1 to the whole power 4 negative 9 upon z plus 1 whole power 5 plus 7 upon z plus 1 to the whole power 6 negative dot dot dot. And this is our required Laurent series expansion of the given complex value function over the given domain, and this is our required final answer.